All right, guys, sorry that first video didn't record any audio, but let's go ahead and go over these slides. So like I said in my directions, the first slide here is vocabulary, and you should recognize all of these words. We've been talking about them for a couple weeks. So what I'm going to do is I'm going to read through the words and the vocabulary definitions. You guys pause and rewind as much as you need to get the right answers. And I suggest that you do the ones you know for sure first, and then try to fit the ones in that you're not sure about after that. So I did the first one for you. Temperature is the average kinetic energy of particles. You've got conduction, convection, thermal energy, conductor, radiation, heat, and insulator. So our definitions that go with these words: a material that does not conduct heat well, heat transfer that occurs through liquids and gases, energy transfer from an object at a higher temperature to an object at a lower temperature, the transfer of heat through direct contact, a material that conducts heat well, the transfer of heat through electromagnetic radiation, and the total kinetic energy of particles. So if you need to, go back and listen to those again and drag those words where they need to go. You can pause and rewind as much as you need to. All right, this next slide, you remember you're going to drag these red check marks into either box of whether the items are a conductor or an insulator. Remember, if you need to review what a conductor and an insulator is, go back to my doodle notes and look at those. The definitions are on there for you. But you've got, I did t-shirt and styrofoam. Those are both insulators. You've got iron, wood, gold, which is a metal, rubber, plastic, and copper, which is another metal. Drag those over whether they are conductors or insulators. Then over here, what happens to the particles in a substance when the temperature rises? We know that all the particles in a substance are moving. What happens to the movement of those particles when you increase the temperature? And then down here, what is the key difference between conductors and insulators? That is one you should definitely be able to answer. So go ahead and pause the video and answer those questions. All right, remember this slide, you're going to drag and drop these over. You're going to put them into the right kind of thermal energy transfer. You've got conduction, convection, and radiation. And once again, if you need to review that, go back to your doodle notes. On this side, we have frying an egg, ironing your clothes, the inside of your car, feeling hot on a summer day, baking a cake, chocolate melting in your hand, a toaster, holding hands, boiling water, and using a heater to keep warm when it's cold. So drag these into the correct box, whether they're an example of conduction, convection, or radiation. On the next slide, remember, we're listening to the 3 different ways to make popcorn. Pay attention to which example is conduction, which one is convection, and which one is radiation, and listen for your evidence. So how did you know which was which? There are 3 different ways to make popcorn for a snack. One way is to make popcorn is to use a microwave. You can put the kernels in a brown paper bag in the microwave, set the timer, and let it do its work for you with the help of electromagnetic waves. Oh, another way to make popcorn is by using an air popper. You can place the kernels in to the machine and then turn it on. The hot air will blow upward, which causes the kernels to circulate in the machine as they heat up until they eventually pop. The third way to cook popcorn is by using a pot on the stove. You can place the pot on top of the surface of the stove and then add kernels inside of the pot. The pot will heat up and the kernels touching the pan will gain more thermal energy until they start to pop. So fill out these boxes. Which method was conduction, convection, and radiation, and how did you know? All right, on this one, remember we're talking about the transfer of thermal energy. We remember that thermal energy goes from the warmer thing to the cooler thing. So I underline the things that should go in your yellow boxes here. So like in this first one, ice and a glass of water. Water is going to be warmer than the ice, so the water is going to transfer thermal energy to the ice. And the next one, you've got a metal spoon and a bowl of hot soup. You've got spoon and soup. Which one is going to have the most thermal energy and transfer it to the cooler thing? Holding your cell phone in your hand for an extended period of time. You got cell phone in hand that are going to go in these yellow boxes. Which one has the most thermal energy that's going to transfer to the thing with the least amount of thermal energy, right? Ice cream in a bowl melts over time. You got the ice cream in the bowl. Which one is going to transfer thermal energy? Which one is warmer and going to transfer to the cooler thing? Blow drying your hair after taking a shower. So here you really got the blow dryer and your hair. Which one is going to be transferring the thermal energy to the cooler thing? And then down here, what happens when two objects at different temperatures come into contact? Think about our gizmo from last week. You had two containers of water at different temperatures. What happened to them when they came into contact? What happened to their temperatures over time? You definitely should be able to answer that one after the gizmo last week. And then our last slide, you guys just need to do this one, and it's a bonus slide for you guys on the greenhouse effect. Do a little research. What is the greenhouse effect, and how does it relate to our heat transfer? What types of heat transfer? Is it conduction, convection, radiation? Just a couple sentences here on how heat transfer relates to the greenhouse. All right, so I know I went through this really fast. It's because I wanted to get it out so you guys could use it today. Please pause it and rewind so that you guys can do really well on this. And then let me know if you have any questions.